Hello everyone, today we're going to look at vectors. A vector is a mathematical object with both magnitude and direction, such as force or velocity. So the difference between speed and velocity is that while they both have a magnitude, only velocity has direction. If I say I'm going 35 miles per hour, that's a speed. If I say I'm going 35 miles per hour northwest, that's velocity. Graphically, they're represented by an arrow. So I have two vectors here, A and B. To denote a vector, we have the letter and then an arrow above it. So that tells me it's the vector A. If I'm looking at the magnitude, then it's just the letter without the arrow. So the magnitude is, again, the 35 in 35 miles per hour northwest. It is also represented by the length of the arrow. So the length of the arrow is the magnitude, which again is the letter without the arrow above it. The direction, the northwest, 35 degrees, southeast or whatever, is represented by an angle, and typically we'll call that angle theta. So in the case of vector A, it has an angle of, say, roughly 60 degrees. If I'm looking at vector B, its angle is 0 degrees. Okay. So we have magnitude, which again is the length of the arrow, and then the direction, which is the angle. When we add vectors graphically, we're going to use what's called the parallelogram method. What we do is we take our two vectors and we join the endpoints together. So where they start, I guess really more than the endpoint, where they start. We put them together, and then we create a parallelogram. So a parallelogram, remember, is a four-sided figure. Each opposite pair of sides is parallel. So we have two copies of A, we have two copies of B, and it's a parallelogram. And then we connect the parallelogram, again, starting at that same common starting spot, and we go through the diagonal. And that diagonal is the addition of the two vectors. So that is the vector A plus B. Typically we're going to call this vector R for the resultant vector, but we'll get into that more when we talk about actually adding them. So today it's just a slight overview. Okay, so we're going to keep this in mind later, again when we do the actual addition. For now, we're going to focus on what's called resolving vectors. Resolving vectors is decomposing a vector into two vectors that add to the original vector, and these two vectors are called components. So if I have two vectors, A plus B, and I add them together to get R, then A and B are called components. Okay. There are several ways that I can resolve a vector, just like there are several ways that I can find two numbers that add up to, say, 10. I could do 8 and 2, 7 and 3, 5 and 5, negative 12 and 2, and so forth. So just resolving a vector, there are an infinite number of ways I can do that. We're going to focus on resolving a vector so that the two components are vertical and horizontal. So this is what it looks like again graphically. I have some vector v. I want two vectors that add to it. So again, remember those are two parts of the parallelogram such that v is the diagonal. Now if my two vectors are horizontal and vertical, my parallelogram just becomes a rectangle. So I am looking for a vertical and horizontal components, again, so parts of v. Notice that they have the same height here, and they have the same length on the going from left to right. So the question is, how do we find these guys? So I have another picture here. And again, the diagonal is my vector in question, my R. I'm not putting the arrows here because I'm talking about the magnitudes, not the vectors themselves. So my vector has magnitude R. The vertical component here has magnitude r sub y, and the horizontal component has magnitude r sub x. So the horizontal component is sometimes called the x component, and the vertical component is sometimes called the y component, just because that's how it is in a Cartesian plane. So again, the question is, and I'm going to erase these lines that I just drew, how do I find r sub x and r sub y? Remember that for a vector, I need both magnitude and direction, but if I know that it's a vertical or a horizontal component, I already know the direction. So all I really care about is the magnitude. So I just want to know how long each of these vectors are. But if I notice, I have very nice right triangles here. So I can use what I know about right triangles to find these guys. So if I know r, which is the hypotenuse of the triangle, and I know an angle, theta, then I can find the two legs by just solving the triangle like we did before. And I'm going to get that r sub x is r cosine theta, and r sub y is r sine theta. And this is coming directly from SOHCAHTOA. If I'm looking for r sub x, then again I know the hypotenuse, and r sub x is the adjacent side to my angle. So I'm using ca. So cosine of theta is adjacent over hypotenuse. And then I just multiply both sides by r. And then very similarly, I'm going to do the same thing with r sub y. R sub y is the same as this guy over here. So it's the opposite. So I'm going to be using so, or sine. Okay, so r sub x is r cosine theta, r sub y is r sine theta. Again, this is exactly from SOHCAHTOA. It's nothing new. It's just new lettering. So we've got r sub x in r instead of a, b, and c. And I have theta instead of a and b. Okay. So we're going to do some examples to resolve the triangle. You're going to be given the magnitude, which again is just the letter without the arrow, and the angle. And all we have to do is plug that into our equation. So a sub x is a cosine theta, and I plug that into my calculator and make sure it's in degree mode, and I get negative 36.86. Again, make sure that you're pausing this and doing this out on your calculator to make sure you're getting the same answers. A sub y is a sine theta, which is negative 25.81. Now, once you've got your two components, you want to make sure your answer makes sense. So I go back and I look at my angle, and I say, what quadrant is 215 degrees in? So I go through and I look at it and I say, okay, that is quadrant 3, right? I've got 180 here, 270 here, so it's somewhere in here. So does it make sense that my a sub x and my a sub y are negative? Hopefully yes, because this is the negative x, this is the negative y. Now remember, the negative is just helping me with direction. So the negative in the a sub x means instead of going to the right, I'm going to the left. Instead of 0 degrees for my direction, it's 180 degrees. The negative in the a sub y means instead of going up, I'm going down. So instead of 90 degrees, I'm going 270 degrees. Okay. So the magnitude for a sub x is really 36.86. But again, that negative is telling me it's going in the opposite direction. So let's try another one. B is 30 and theta is 135 degrees. So b sub x is b times cosine of theta, which is negative 21.21. And b sub y is b cosine theta, b sine theta, which is positive 21.21. Again, we'll double check this, make sure it makes sense. 135 degrees is right here, so it's quadrant 2. So x is negative, y is positive. And it's also true that their magnitudes, again, in absolute value, are the same, because 135 is the same as that 45 degrees, but in the other quadrant. So your x and your y components should have the same length. And again, this negative just tells me that it's going 180 degrees, not 0 degrees. Okay, so let's try another one. C is 20, theta is 15. C sub x is C cosine theta, 19.32. C sub y is C sine theta, is 5.17. 15 degrees is quadrant 1. So both my C sub x and my C sub y are positive, so that makes sense. I can even go a little bit further. We know that 15 degrees is a fairly small angle, so it looks something like this, which means if I break it down, I've got my C sub y over here, my C sub x over here. My C sub x should be a lot longer than my C sub y. So don't forget, you can always check, does my answer make sense in more than just the sign direction? My C sub x, I know, should be larger than my C sub y. So I didn't accidentally switch the two. Okay, so that's something you can always check. So let's try one last example. D equals 137, theta is 307 degrees. So D sub x, D cosine theta, 82.45. D sub y, D sine theta, negative 109.41. So again, we look at where is 307 degrees. So we know this is 270, this is 360. So it's somewhere in here. So I know that my x should be positive, my y should be negative. That's good. Okay, so again, you should always at least check that the sign SIGN is correct for both of your components. So this is a fairly straightforward section. Again, it's nothing new, it just has new labels or new names to it. But the math itself is something we've been doing for a little while now. So try it out and let me know if you have any questions. Thanks.